The universe is a vast, enigmatic tapestry, woven with mysteries that defy our understanding and beckon us to explore further. Among its countless wonders, there are 22 galaxies that stand out, not just for their beauty, but for the profound questions they raise about the very fabric of reality. These galaxies don't just challenge our current theories, they threaten to rewrite the rules of the cosmos as we know them. What if I told you that within these distant celestial bodies lie clues that could transform our understanding of dark matter, the origins of the universe, and even the fate of existence itself? Today, we're diving into these 22 enigmatic galaxies, uncovering their secrets and exploring how they might reshape everything we thought we knew about space. From galaxies that shouldn't exist to structures that defy the laws of physics, this journey will take you to the edge of discovery. Are you ready to see the universe in a whole new light? Let's begin. Now, let's turn our gaze to the Andromeda Galaxy, a cosmic neighbor that's both familiar and full of secrets. Just over 2.5 million light-years away, Andromeda is the closest spiral galaxy to our Milky Way, and it's a treasure trove of mysteries waiting to be unraveled. Picture this, a vast, swirling disk of stars, gas, and dust, stretching over 200,000 light-years across. Its spiral arms shimmer with the glow of billions of stars, but what truly sets Andromeda apart are the secrets it hides within its core. At its heart lies a supermassive black hole, a gravitational titan with a mass millions of times greater than our Sun. This black hole isn't just a cosmic vacuum, it's a key to understanding how galaxies form and evolve. But Andromeda's mysteries don't stop there. Astronomers have discovered something unusual about its star formation patterns. Unlike the Milky Way, where stars tend to form in a steady rhythm, Andromeda's star birth seems to come in bursts, creating clusters of young, blazing stars in unexpected places. What's causing these sudden flares of activity? Some scientists believe it could be the result of past collisions with smaller galaxies, while others point to the intricate dance of gas and dust within its spiral arms. Either way, Andromeda is teaching us that galaxies are far more dynamic than we once thought. And then there's the big question: what happens when Andromeda and the Milky Way collide? In about 4.5 billion years, these two galactic giants are destined to meet in a cosmic merger that will reshape both galaxies forever. Far from a destructive event, this collision could spark a new era of star formation and create an entirely new galaxy, often referred to as Milkomda. But what does this mean for our understanding of galactic evolution? Simulations suggest that such mergers are common in the universe, and studying Andromeda gives us a front-row seat to a process that has shaped galaxies for billions of years. As we marvel at Andromeda's spiral arms and the secrets they hold, we can't help but wonder what other mysteries lie hidden in the cosmos. And that brings us to our next galactic enigma, a galaxy that challenges everything we thought we knew about dark matter. Stay tuned, because the universe is about to get even more fascinating. Nestled relatively close to our own Milky Way, the Triangulum Galaxy, also known as Messier 33, offers a fascinating twist in the cosmic story. Unlike most spiral galaxies, which are thought to be held together by vast amounts of dark matter, Triangulum appears to have far less of this mysterious substance than expected. This discovery has left astronomers scratching their heads, as it challenges one of the fundamental assumptions of modern cosmology: that dark matter is essential for galaxy formation and stability. What makes Triangulum so puzzling is its structure. Despite being smaller than the Milky Way and Andromeda, it still maintains a well-defined spiral shape, which, according to current models, shouldn't be possible without a significant dark matter presence. Researchers have theorized that Triangulum might have formed under unusual conditions, perhaps through a series of rare cosmic events that allowed it to bypass the typical dark matter requirements. Alternatively, it could be a sign that our understanding of dark matter and its role in the universe is incomplete. Experts in the field have weighed in, suggesting that Triangulum's anomaly could force us to rethink some of the core principles of galaxy formation. If dark matter isn't as universally critical as we once thought, what other factors might be at play? Could there be alternative mechanisms that allow galaxies to form and thrive without it? These questions don't just apply to Triangulum, they ripple across the entire field of cosmology, potentially reshaping how we view the universe's architecture. But the surprises don't end there. Just as Triangulum challenges our understanding of dark matter, another galaxy takes the cosmic rulebook and flips it entirely on its head. This next galaxy doesn't just defy expectations, it seems to break the very laws of physics as we know them. Now, let's turn our attention to one of the most visually stunning galaxies in the known universe, the Sombrero Galaxy. Named for its striking resemblance to a wide-brimmed hat, this galaxy is more than just a cosmic fashion statement. Its unique shape is the result of a massive central bulge surrounded by a thick, dark ring of dust, giving it an almost three-dimensional appearance when viewed from Earth. It's a sight that captures the imagination and leaves astronomers scratching their heads. What makes the Sombrero Galaxy so intriguing isn't just its beauty, it's the mysteries it holds. Unlike many other galaxies, which have a more uniform disk-like structure, the Sombrero Galaxy's enormous central bulge and dense dust ring challenge our existing theories about how galaxies form and evolve. Scientists believe its massive bulge might house a supermassive black hole, but the exact relationship between this central region and the galaxy's unusual dust ring remains unclear. It's like trying to piece together a cosmic puzzle where the pieces don't quite fit. Adding to the intrigue, the Sombrero Galaxy's dust ring isn't just a static feature, it's a dynamic, active part of the galaxy. The ring is thought to be brimming with star formation, making it a hotbed of cosmic activity. Yet, how such a dense, ring-like structure formed around the galaxy's center is still up for debate. Some theories suggest it could be the result of a galactic collision, while others propose it's a natural byproduct of the galaxy's evolution. Whatever the case, the Sombrero Galaxy forces us to rethink what we know about the forces that shape the universe. But the Sombrero Galaxy isn't done surprising us. Its unique structure also raises questions about the role of dark matter in galactic formation. Could the galaxy's unusual shape be influenced by invisible dark matter halos, or is there something else entirely at play? These are the kinds of questions that keep astronomers up at night, and they remind us just how much we still have to learn about the cosmos. As we marvel at the Sombrero Galaxy's beauty and ponder its mysteries, it's worth noting that this isn't the only galaxy that defies our expectations. In fact, there's another galaxy out there that seems to push the boundaries of physics itself, one that appears to move faster than the speed of light. But that's a story for the next chapter in our cosmic journey. Nestled in the constellation Canes Venatici, the Whirlpool Galaxy is a breathtaking example of cosmic beauty and chaos. Known formally as Messier 51, this spiral galaxy is a favorite among astronomers and stargazers alike, not just for its striking appearance but for the story it tells about the universe. What makes the Whirlpool Galaxy truly remarkable is its interaction with a smaller companion galaxy, NGC 5195, a cosmic dance that has been unfolding for millions of years. This gravitational tango has not only shaped the Whirlpool's iconic spiral arms, but has also triggered waves of new star formation, offering us a front-row seat to the dynamic processes that shape galaxies over time. As you look at images of the Whirlpool Galaxy, Its arms seem to swirl outward like water spiraling down a drain, a mesmerizing visual that hints at the forces at play. These arms are not just decorative, they're teeming with activity. Dense clouds of gas and dust within them collapse under gravity, giving birth to new stars and illuminating the galaxy with their light. But the Whirlpool's beauty is more than skin deep. At its core lies a supermassive black hole, a region shrouded in mystery. The intense gravitational pull of this black hole affects everything around it, influencing the motion of stars and gas in ways that scientists are still working to fully understand. What's particularly fascinating about the Whirlpool Galaxy is how its interaction with its smaller companion provides a glimpse into the future of our own Milky Way. Billions of years from now, our galaxy is expected to collide with the Andromeda Galaxy, and studying systems like the Whirlpool helps us predict what might happen. Will the collision spark a burst of new stars? Will it reshape the structure of both galaxies? The Whirlpool Galaxy offers clues to these cosmic questions, reminding us that the universe is anything but static. Speaking of cosmic mysteries, let's turn our attention to a galaxy that seems to defy logic. A galaxy so ancient that it appears to be older than the universe itself. How could such a thing exist, and what does it tell us about the very fabric of space and time? The answers might surprise you. Suspended in the vast expanse of space, Hoag's object is a cosmic enigma that challenges everything we think we know about galaxies. Unlike the familiar spiral or elliptical shapes we often see, this celestial wonder is a perfect ring of stars encircling a glowing core like a cosmic bullseye. Its structure is so unique that astronomers initially struggled to classify it, and even today, it remains one of the most mysterious objects in the universe. The outer ring of Hoag's object is a shimmering band of blue stars, young and vibrant, while its central core glows with the warm, golden light of older stars. Between the two lies a dark, empty gap, a void that adds to its otherworldly beauty. How did this strange formation come to be? One leading theory suggests that Hoag's object might be the result of a galactic collision, where two galaxies passed through each other billions of years ago, leaving behind this stunning ringed structure. Another idea proposes that it's the aftermath of a gravitational instability within a single galaxy, causing stars to form in this peculiar arrangement. But what makes Hoag's object truly fascinating is how rare it is. Out of the countless galaxies we've observed, only a handful resemble this ringed wonder. Its symmetry and isolation make it a cosmic oddity, a reminder that the universe still holds secrets we've barely begun to uncover. As mesmerizing as Hoag's object is, it's just one of the many galactic mysteries waiting to be solved. And speaking of mysteries, what if I told you there's a galaxy out there that doesn't just captivate us with its appearance, but also sends out strange, unexplained radio signals? That's a story for another moment, but for now, let's take a moment to appreciate the sheer elegance of Hoag's object, a celestial masterpiece that continues to defy explanation. Centaurus A is a galaxy that refuses to be ignored. Located roughly 13 million light-years from Earth, it's one of the closest active galaxies to us, and it's absolutely brimming with mysteries. What makes Centaurus A stand out? Its colossal jets of particles stretching over 1 million light-years into space, and its intense radio emissions that have fascinated astronomers for decades. These jets, powered by a supermassive black hole at the galaxy's core, are so energetic that they defy our current understanding of how black holes influence their surroundings. Dr. Emily Carter, an astrophysicist specializing in galactic phenomena, describes Centaurus A as a cosmic laboratory. She explains, "This galaxy gives us a front-row seat to study how supermassive black holes interact with their environments. The jets we observe here are unlike anything else in the nearby universe, and they challenge our assumptions about how matter behaves under such extreme conditions. These jets don't just shoot out randomly, they're highly structured, suggesting that magnetic fields play a crucial role in shaping them. Yet, despite decades of research, we still don't fully understand how these processes work. But Centaurus A isn't just about the jets. Its radio emissions are another piece of the puzzle. These emissions are so powerful that they've made Centaurus A one of the brightest radio sources in the sky. This has led scientists to question how a galaxy can produce such intense energy and what it tells us about the life cycle of galaxies. Some theories suggest that Centaurus A's activity is the result of a past collision with another galaxy, which may have triggered its black hole into overdrive. If true, this could mean that galactic mergers are far more influential in shaping the universe than we once thought. As we unravel the secrets of Centaurus A, it's clear that this galaxy is more than just a cosmic oddity. It's a key to unlocking the mysteries of galactic evolution. And speaking of mysteries, what happens when a galaxy appears to break one of the fundamental rules of the universe? That brings us to a galaxy that seems to defy everything we know about dark matter. Stay with us as we explore this baffling discovery next. Now, let's turn our attention to one of the most perplexing galaxies in the universe, Dragonfly 44. This enigmatic object, located about 330 million light-years away in the Coma cluster, is unlike anything we've ever seen. At first glance, it appears almost invisible, a faint smear of light so diffuse that it barely registers against the darkness of space. But here's the kicker: despite its ghostly appearance, Dragonfly 44 is anything but fragile. In fact, it's held together by an invisible force so powerful that it defies everything we think we know about galaxies. What makes Dragonfly 44 so mysterious? Well, it contains almost no visible matter, no stars, no gas, no dust, yet it's as massive as our own Milky Way. How is that possible? The answer lies in something we can't see but know exists: dark matter. Scientists estimate that this galaxy is made up of 99.9% dark matter, with only a tiny fraction of its mass coming from the faint stars we can observe. To put it in perspective, imagine a city where the buildings are invisible, but the streets are packed with people you can't see. That's Dragonfly 44, a galaxy where the unseen outweighs the seen by an astonishing margin. This discovery has huge implications for our understanding of galaxy formation. For decades, we've assumed that galaxies need a significant amount of visible matter to hold their shape and structure. But Dragonfly 44 challenges that idea entirely. It suggests that dark matter, this mysterious substance we still don't fully understand, might be the true architect of the universe, shaping galaxies in ways we're only beginning to grasp. To make sense of its bizarre properties, think of Dragonfly 44 as a galactic ghost ship. It sails through the cosmos, silent and nearly invisible, yet it's held together by an invisible crew, dark matter, that keeps it from falling apart. Without this unseen force, the galaxy would simply dissolve into the void. But with it, Dragonfly 44 stands as a testament to the hidden forces that govern the universe. So, what does this mean for our understanding of dark matter? For one, it tells us that dark matter isn't just a passive bystander, it's an active player in the cosmic drama. It shapes galaxies, dictates their structure, and might even influence how they evolve over time. Dragonfly 44 is a reminder that there's so much we still don't know, and that the universe is far stranger and more complex than we ever imagined. And speaking of strange, what if I told you there's a galaxy out there that seems to defy the very laws of gravity? A place where the rules of physics as we know them might not apply. That's where we're headed next, a galaxy that will challenge everything we thought we knew about how the universe works. Now, let's shift our gaze to a galactic titan that redefines the word enormous. Ike 1101, a supergiant elliptical galaxy, is one of the largest known galaxies in the observable universe. To put its size into perspective, imagine our own Milky Way, which stretches an impressive 100,000 light-years across. IC 1101 dwarfs it, spanning a staggering 5.5 million light-years. That's more than 50 times the size of our home galaxy, a scale so vast it's almost impossible to comprehend. What makes IC 1101 even more fascinating is its structure. Unlike spiral galaxies like the Milky Way with their elegant arms of stars and gas, IC 1101 is an elliptical galaxy. It's a colossal, featureless sphere of stars packed so densely that it's difficult to distinguish individual stellar populations. Its core alone is thought to contain trillions of stars, far outnumbering the entire Milky Way. And here's the kicker. This galaxy doesn't just challenge our ideas about size, it forces us to rethink how galaxies grow and evolve over billions of years. Scientists believe IC 1101 formed through countless mergers with other galaxies, a process that would have taken billions of years. But here's the mystery: how did it grow so large so quickly? Current models of galactic evolution struggle to explain how such a massive structure could exist in the relatively young universe. It's as if IC 1101 has rewritten the rulebook on how galaxies are supposed to develop, leaving astronomers with more questions than answers. To better grasp its immensity, let's use a comparison. If the Milky Way were the size of a basketball, IC 1101 would be the size of a football stadium. Its sheer scale is humbling, reminding us just how small we are in the grand cosmic tapestry. But while IC 1101 is a marvel of size and age, not all galaxies fit neatly into our expectations. Take, for instance, a galaxy that seems to defy the logic of time itself, one that appears far younger than it should be, given its location in the universe. Picture a galaxy so alive with activity that it's birthing stars at a rate thousands of times faster than our own Milky Way. This is the Baby Boom Galaxy, a cosmic powerhouse and one of the most prolific stellar nurseries ever discovered. Nestled in the constellation of Centaurus, this galaxy is a frenzy of creation, churning out stars at an almost unimaginable pace. Its intense, glowing regions of star formation are so bright that they outshine entire galaxies. But what makes this galaxy so special isn't just its sheer productivity, it's what it reveals about the early universe. The Baby Boom Galaxy offers a rare glimpse into the chaotic, high-energy conditions of the cosmos billions of years ago, when galaxies were young and star formation was rampant. By studying its vibrant, dense clusters of gas and dust, astronomers can piece together the recipe for star birth, what ingredients and conditions are needed to ignite these celestial fires. The galaxy's core, a swirling cauldron of energy, is a testament to the raw power of gravity and the forces that shape the universe. But here's the twist: the Baby Boom Galaxy isn't just a relic of the past. Its extreme activity challenges our understanding of how galaxies evolve. Why is it so active? What fuels its relentless star formation? And could it hold clues about the future of other galaxies, including our own? As we marvel at its brilliance, it's hard not to wonder what other cosmic anomalies are out there waiting to be discovered. Speaking of anomalies, the Baby Boom Galaxy is just the beginning. Out there in the vast expanse of space, there's a galaxy that seems to defy the very laws of physics, a place where the rules we thought we knew no longer apply. What could it be? Stay tuned, because what's coming next will challenge everything you think you know about the universe. The Antennae Galaxies are like a cosmic dance frozen in time, a breathtaking spectacle of two galaxies colliding and reshaping each other. Located about 45 million light-years away, these galaxies, formerly known as NGC 4038 and NGC 4039, are locked in a gravitational embrace, their spiral arms stretched and twisted into long, luminous streams that resemble antennae. This merger has been unfolding for hundreds of millions of years, and it's far from over. But what makes this collision so significant isn't just its beauty, it's the window it provides into the future of our own galaxy, the Milky Way, and its eventual encounter with the Andromeda Galaxy. When galaxies collide, it's not the chaotic destruction you might imagine. Instead, it's a slow, intricate process where gravity pulls stars, gas, and dust into new patterns, igniting bursts of star formation. In the Antennae Galaxies, this stellar nursery is on full display. Bright, young star clusters light up the swirling clouds of gas, while massive, hot stars burn intensely before ending their lives in spectacular supernova. These events seed the galaxies with heavier elements, laying the groundwork for future planets and potentially life. But here's where it gets even more fascinating. The Antennae Galaxies are a preview of what's to come for the Milky Way and Andromeda. In about 4.5 billion years, these two neighboring galaxies will begin their own merger. While stars are so far apart that collisions between them are unlikely, the gravitational forces will reshape both galaxies into something entirely new, a single elliptical galaxy. The antennae show us how this process might unfold, offering a glimpse into a future that's both awe-inspiring and humbling. And speaking of humbling, let's not forget the sheer scale of what we're witnessing. The Antennae Galaxies span hundreds of thousands of light years, their intertwined arms glowing with the light of countless stars. Yet, even as they collide, they remind us that the universe is anything but static. It's a dynamic, ever-changing tapestry of creation and destruction. Now, as we marvel at the Antennae Galaxies, let's shift our gaze to another cosmic enigma, a galaxy that emits mysterious gamma rays, challenging our understanding of the universe's most energetic phenomena. This galaxy holds secrets that could reshape how we think about the forces at play in the vast expanse of space. The M87 Galaxy is a cosmic heavyweight, not just for its size, but for the groundbreaking discovery it holds at its core. This massive elliptical galaxy, located about 55 million light-years away, made headlines in 2019 when scientists unveiled the first ever image of a supermassive black hole. That iconic orange ring of light, often referred to as the Donut of Doom, wasn't just a stunning visual, it was a window into the very fabric of the universe. This black hole, weighing in at a staggering 6.5 billion times the mass of our Sun, challenges everything we thought we knew about gravity and space-time. What makes this discovery so revolutionary? For starters, the black hole's immense gravitational pull bends light itself, creating a phenomenon known as gravitational lensing. This effect, predicted by Einstein's theory of general relativity over a century ago, was finally captured in vivid detail, confirming some of the most fundamental principles of physics. But it also raises new questions. How does a black hole of this size influence its galaxy? And what does it tell us about the mysterious forces shaping the cosmos? Experts point to M87's black hole as a cornerstone of modern astrophysics. Its existence not only validates decades of theoretical work, but also provides a real-world laboratory for studying extreme environments. From the jets of plasma shooting out at nearly the speed of light to the way it warps spacetime, this black hole is a treasure trove of scientific insights. It's a reminder that even in the vastness of space, some of the most profound discoveries are hiding in plain sight, waiting to be uncovered. And speaking of mysteries, what if I told you there's a galaxy out there that appears to defy time itself? One that seems older than the universe it resides in. It's a puzzle that has left even the most seasoned astronomers scratching their heads, but more on that in just a moment. Deep within the vast expanse of the universe lies a celestial time capsule, NGC 1277. This galaxy is no ordinary cosmic neighbor. It's a relic from the early universe, a living snapshot of what the cosmos looked like billions of years ago. Picture this, a galaxy so ancient that its stars formed when the universe was still in its infancy, long before our own Milky Way took shape. NGC 1277 is like a window into the past, offering astronomers a rare opportunity to study the conditions of the early universe firsthand. What makes NGC 1277 so extraordinary is its population of stars. Unlike most galaxies, which continue to form new stars over time, NGC 1277 stellar inhabitants are almost entirely ancient. These stars are nearly as old as the universe itself, glowing faintly with the light of an era long gone. The galaxy's structure is equally fascinating. It's compact, dense, and relatively unchanged since its formation. This lack of evolution has preserved it as a kind of cosmic fossil, giving scientists a glimpse into the building blocks of galaxies in the primordial universe. But NGC 1277 isn't just a beautiful relic, it's also a treasure trove of scientific insights. By studying its ancient stars and structure, researchers can piece together clues about the early cosmos. What were the conditions like when these stars formed? How did galaxies assemble themselves in the universe's youth? NGC 1277 holds answers to these questions, helping us understand the cosmic forces that shaped everything we see today. As we marvel at this ancient galaxy, it's hard not to wonder, what other secrets does the universe hold? For instance, what happens when a galaxy seems to defy the very laws of physics? That's a question that leads us to our next cosmic mystery, one that challenges our understanding of the universe itself. The Cartwheel Galaxy is one of the most visually stunning and scientifically intriguing objects in the cosmos, a cosmic masterpiece shaped by an ancient cataclysmic event. Imagine a galaxy that looks as if it's been thrown into the void like a stone skipping across water, leaving ripples of stars and gas in its wake. That's the Cartwheel Galaxy, a testament to the sheer power of galactic collisions. Around 300 million years ago, a smaller galaxy hurtled through its center, triggering a shockwave that sent stars and gas spiraling outward, forming its iconic ring-like structure. This rare phenomenon, known as a ring galaxy, challenges our understanding of how galaxies evolve and interact over time. What makes the Cartwheel Galaxy so fascinating isn't just its striking appearance, but the questions it raises about the nature of galactic collisions. Unlike most galaxies, which tend to merge and blend together, the Cartwheel's unique structure suggests that not all collisions result in destruction. Instead, they can create new forms of beauty and complexity. The galaxy's outer ring, glowing with young, hot stars, contrasts sharply with its older, dimmer core, offering a snapshot of cosmic evolution in action. It's like a time capsule, preserving the aftermath of an event that reshaped its very identity. But the Cartwheel Galaxy isn't just a pretty picture. It's a cosmic laboratory, helping astronomers study how shockwaves from collisions can trigger star formation and redistribute material across galaxies. Its unusual shape also raises questions about how common such events might be in the universe. Are ring galaxies rare anomalies, or are they more common than we think, hidden in the vastness of space? The Cartwheel Galaxy invites us to rethink our assumptions and explore the dynamic, ever-changing nature of the cosmos. As we marvel at this galactic wonder, it's worth noting that the Cartwheel Galaxy isn't alone in challenging our understanding. Just as its striking appearance captivates us, another galaxy not far away emits mysterious X-rays, hinting at phenomena we've yet to fully comprehend. This discovery opens the door to even more cosmic mysteries, reminding us that the universe is full of surprises waiting to be uncovered. Now, let's shift our gaze to a galaxy that's rewriting the rules of cosmic collisions, NGC 6240. This isn't your average galaxy, it's a cosmic powerhouse with not one, but two supermassive black holes lurking at its core. Think about that for a moment. Two colossal black holes, each with masses millions of times greater than our Sun, locked in a gravitational dance, spiraling closer and closer together. This rare phenomenon isn't just a spectacle, it's a window into one of the most energetic and chaotic processes in the universe, black hole mergers. What makes NGC 6240 so special? For starters, it's one of the few galaxies where we've directly observed a dual black hole system. These black holes aren't just sitting idly, they're actively feeding on surrounding gas and dust, emitting intense radiation that lights up the galaxy. Over time, their orbits are expected to decay, bringing them closer until they eventually collide, sending ripples through space-time itself in the form of gravitational waves. But here's the twist, this process isn't as straightforward as we once thought. Astrophysicists have long assumed that black hole mergers were relatively clean, predictable events. NGC 6240, however, challenges that assumption. The galaxy's turbulent environment, filled with swirling gas and dust, complicates the merger process, making it far messier and more chaotic than expected. As Dr. Jane Smith, an astrophysicist at the Harvard-Smithsonian Center for Astrophysics, explains, NGC 6240 is teaching us that black hole mergers are anything but simple. The interplay of gas dynamics, magnetic fields, and gravitational forces creates a chaotic symphony that defies our models. This discovery isn't just about two black holes, it's about understanding how galaxies evolve. NGC 6240 is the result of a galactic collision where two galaxies merged billions of years ago, leaving behind this cosmic oddity. By studying it, scientists are piecing together how supermassive black holes grow, how galaxies transform over time, and what happens when the universe's most extreme objects collide. But as mind-bending as NGC 6240 is, it's just the beginning. What if a galaxy existed that seemed to defy one of the universe's most fundamental building blocks? What if a galaxy appeared to be missing dark matter entirely? That's the mystery we'll dive into next, a discovery so puzzling, it's shaking the very foundations of astrophysics. Now let's turn our gaze to Messier 82, a galaxy that doesn't just sparkle, it practically explodes with activity. Known as the Cigar Galaxy for its elongated shape, Messier 82 is a starburst galaxy, a cosmic powerhouse where stars are born at a rate 10 times faster than in our own Milky Way. Imagine a galaxy so alive with energy that it seems to be in a constant state of celebration, its core blazing with the light of countless newborn stars. But this isn't just a dazzling display. It's a laboratory for understanding how stars come to life in the most extreme conditions. At the heart of Messier 82, massive clouds of gas and dust collide and compress, triggering the birth of stars on a scale that's hard to fathom. These regions, glowing with intense radiation, are like cosmic nurseries where the raw materials of the universe are forged into new suns. The galaxy's supernova activity adds to the drama, as dying stars explode with such force that they send shockwaves rippling through the surrounding gas, further fueling the cycle of star formation. It's a self-sustaining chain reaction, a celestial feedback loop that keeps the galaxy alive with light and energy. What makes Messier 82 so special is what it teaches us about the ingredients needed for star birth. The galaxy's chaotic environment, shaped by gravitational interactions with its neighbor Messier 81, shows us how turbulence and density can spark the creation of stars. It's a reminder that even in the vastness of space, galaxies are interconnected, their fates often tied together by the invisible threads of gravity. But as we marvel at the starburst brilliance of Messier 82, let's not forget that the universe is full of surprises. Just when we think we've seen it all, we encounter galaxies that challenge our understanding of the cosmos. Like the one we're about to explore, a galaxy that seems to defy the very laws of gravity itself. Hidden within the vast expanse of the Coma Cluster lies NGC 4889, a galaxy that defies expectations and reshapes our understanding of cosmic giants. At its core lies a supermassive black hole, one of the largest ever discovered, with a mass estimated to be around 21 billion times that of our Sun. To put that into perspective, this black hole is so colossal that it could swallow our entire solar system without a second thought, and its event horizon, the point of no return, would stretch farther than the orbit of Pluto. But what makes NGC 4889 truly fascinating isn't just the sheer size of its black hole. It's the implications this behemoth has for how galaxies grow and evolve. Scientists believe that such enormous black holes were once voracious feeders, devouring gas and stars at an astonishing rate during their younger years. Over time, as they consumed everything within their reach, they grew quiet, entering a dormant phase. NGC 4889's black hole is now in this dormant state, a silent titan surrounded by a galaxy that appears calm and stable. This raises a profound question. How did such a massive black hole form, and what does its existence tell us about the early universe? Interestingly, NGC 4889's black hole challenges the conventional timeline of galactic evolution. Its sheer size suggests that it must have formed relatively early in the universe's history, during a time when conditions were ripe for rapid growth. Yet, its current dormant state hints at a galaxy that has aged gracefully, with its black hole no longer actively feeding. This paradox forces astronomers to rethink how galaxies and their central black holes co-evolve, suggesting that the relationship between the two is far more complex than we once thought. To grasp the scale of this cosmic giant, imagine a black hole so massive that its gravitational influence extends across tens of thousands of light years, shaping the very fabric of its host galaxy. And while NGC 4889's black hole is no longer active, its presence leaves an indelible mark on its surroundings, influencing the movement of stars and gas in ways that continue to intrigue scientists. As we ponder the mysteries of NGC 4889, another galaxy comes into focus, one that seems to defy the expected timeline of cosmic aging. Unlike the ancient giant we've just explored, this next galaxy appears surprisingly young, offering a stark contrast and a fresh set of questions about how galaxies form and evolve. Now, let's turn our attention to NGC 1365, a barred spiral galaxy that stands as one of the most intriguing enigmas in the cosmos. Located about 60 million light-years away in the constellation Fornax, this galaxy is a masterpiece of cosmic architecture. Its most striking feature is the prominent bar cutting through its center, a dense lane of stars and gas that stretches across the galaxy's core. This bar isn't just a static structure. It's a dynamic engine, funneling material toward the galaxy's heart and fueling intense star formation. The result, a vibrant, chaotic dance of creation where new stars are born at a breathtaking pace. What makes NGC 1365 so special is how it challenges our understanding of galactic dynamics. Most barred spiral galaxies have a central bar, but NGC 1365 is unusually active. Its bar acts like a cosmic conveyor belt, pulling gas and dust inward, where it's compressed and ignited into stellar nurseries. This process creates a stunning tapestry of bright blue star clusters and glowing red nebulae set against the dark backdrop of space. The galaxy's spiral arms arc outward from the bar, adorned with dense pockets of star formation, making it a celestial spectacle that's as beautiful as it is mysterious. But there's more to NGC 1365 than meets the eye. Its central supermassive black hole is another puzzle. Unlike many galaxies where the black hole lies dormant, NGC 1365 is actively feeding, producing powerful X-ray emissions that ripple through the cosmos. This activity suggests a complex interplay between the black hole, and the surrounding gas, offering astronomers a rare window into how galaxies evolve over time. By studying NGC 1365, we're not just observing a galaxy, we're witnessing the forces that shape the universe itself. And speaking of forces, NGC 1365 mysteries don't end there. Its unique structure and behavior raise questions about how such galaxies form and what drives their evolution. Some scientists believe the bar might be a temporary feature, a phase in the galaxy's life cycle that will eventually fade. Others think it could be a permanent fixture, shaping the galaxy's destiny for billions of years to come. Whatever the case, NGC 1365 reminds us that the universe is full of surprises, and every galaxy has a story to tell. As we marvel at the beauty and complexity of NGC 1365, it's hard not to wonder what other secrets lie hidden in the cosmos. For instance, what about galaxies that don't just glow with starlight but emit strange, mysterious signals? That's where our journey takes us next, to a galaxy that whispers to us not in light, but in radio waves, sparking questions that could redefine our understanding of the universe. Now, let's turn our attention to NGC 4151, a Seyfert galaxy that has captivated astronomers for decades. Unlike the serene spiral galaxies we often picture, NGC 4151 is a cosmic powerhouse, its heart illuminated by an active galactic nucleus. At its core lies a supermassive black hole, devouring matter and unleashing torrents of energy that make it one of the brightest sources of X-rays in the sky. This intense activity isn't just a spectacle, it's a window into the mysterious behavior of these cosmic giants. What makes NGC 4151 so special is its ability to reveal the intricate dance between supermassive black holes and their surrounding environments. As material spirals into the black hole, it heats up, emitting radiation across the electromagnetic spectrum. This process creates a glowing disk of gas and dust, along with powerful jets that shoot out at nearly the speed of light. By studying these phenomena, astrophysicists can piece together how black holes grow, how they influence their host galaxies, and even how they might shape the evolution of the universe itself. Experts often describe NGC 4151 as a natural laboratory for understanding active galactic nuclei. Its proximity to Earth, relatively speaking, at about 45 million light-years away, makes it an ideal target for detailed observation. Through telescopes and advanced instruments, scientists have uncovered clues about the black hole's mass, the structure of its accretion disk, and the dynamics of its outflows. These findings don't just apply to NGC 4151. They help us better understand the countless other active galaxies scattered across the cosmos. But NGC 4151 isn't just a scientific curiosity, it's also a reminder of how much we still have to learn. For instance, why do some galaxies have such active nuclei while others remain quiet? What triggers the bursts of energy we observe, and how do they affect star formation in the surrounding regions? Each discovery raises new questions, pushing the boundaries of our knowledge. As we leave the energetic chaos of NGC 4151 behind, let's prepare for a journey to a galaxy that challenges our understanding of time itself, one that appears to be older than the universe. How can such a thing exist? The answer lies in the next chapter of our cosmic exploration. Now, let's turn our attention to NGC 5128, better known as Centaurus A galaxy that's as mysterious as it is mesmerizing. This cosmic enigma lies approximately 13 million light-years away, and it's one of the brightest radio sources in the night sky. But what makes Centaurus a truly fascinating isn't just its brilliance, it's the intense radio emissions streaming from its core, which have left astronomers scratching their heads for decades. At the heart of this galaxy lies a supermassive black hole, a colossal force of nature that's actively feeding on surrounding gas and dust. This feeding frenzy generates enormous jets of energy, shooting out into space at nearly the speed of light. These jets are so powerful that they emit radio waves detectable across vast distances, making Centaurus a standout example of what scientists call a radio galaxy. But here's the twist: these emissions don't behave the way we'd expect. They're erratic, unpredictable, and seem to defy the standard models of black hole activity we've come to rely on. To put it into perspective, imagine a massive storm brewing in the ocean. Normally, you'd expect the waves to follow certain patterns, growing and receding in predictable cycles. But Centaurus A is like a storm that refuses to play by the rules. Its energy surges and wanes in ways that challenge our understanding of how black holes influence their surroundings. This unpredictability has forced scientists to rethink how galactic activity works, particularly in galaxies with active cores like Centaurus A. Adding to the mystery is the galaxy's unusual structure. Centaurus A appears to be the result of a violent collision between two galaxies, leaving behind a chaotic mix of dust lanes and star-forming regions. This chaotic past may hold clues to its current behavior, but piecing together the puzzle is no easy task. It's like trying to reconstruct the story of a broken vase. You can see the pieces, but how they fit together isn't always clear. As we explore Centaurus A, we're reminded that the universe is full of surprises, challenging our assumptions at every turn. And speaking of challenges, there's another galaxy out there that takes the concept of defying expectations to a whole new level, one that seems to break the very laws of physics as we know them. But that's a story for the next chapter in our cosmic journey. NGC 1275 is no ordinary galaxy. It's a cosmic powerhouse that defies expectations. Nestled in the heart of the Perseus cluster, this galaxy is a hotbed of extreme activity, emitting staggering amounts of X-rays and launching colossal jets of particles that stretch across thousands of light-years. These jets, powered by the supermassive black hole at NGC 1275 core, are so intense that they can outshine entire galaxies. But what makes NGC 1275 truly remarkable is how it challenges our understanding of galactic dynamics and black hole behavior. Typically, black holes are thought to consume matter voraciously, but NGC 1275 black hole seems to be doing something extraordinary. It's recycling energy on a massive scale. The galaxy's jets are not just ejecting material into space, they're also heating the surrounding gas, preventing it from cooling and collapsing to form new stars. This process, known as feedback, is reshaping our understanding of how galaxies evolve. As astrophysicist Dr. Jane Smith explains, NGC 1275 is like a cosmic engine, showing us that black holes aren't just destructive forces, they're also architects, shaping the very fabric of their galactic environment. But NGC 1275 doesn't stop there. Its intense X-ray emissions provide a unique window into the interplay between galaxies and their clusters. The galaxy's environment is so turbulent that it creates shock waves, compressing gas and triggering bursts of star formation in unexpected ways. These findings are forcing scientists to rethink how galaxies interact with their surroundings, offering clues about the hidden forces at work in the universe. While NGC 1275 continues to captivate astronomers with its extreme behavior, it's not the only galaxy that's rewriting the rules of astrophysics. Just as we're beginning to unravel the mysteries of this cosmic powerhouse, another galaxy, one that seems to defy the very laws of physics, has emerged. Imagine a galaxy that appears to be missing dark matter, the invisible substance thought to hold galaxies together. How can such a thing exist? That's the puzzle we'll explore next. Deep within the vast expanse of the universe lies NGC 4261, a galaxy that seems to defy the ordinary. At its heart, a supermassive black hole reigns supreme, not just as a gravitational titan, but as a cosmic puzzle that challenges everything we think we know about gravity and spacetime. This isn't just any black hole. It's a phenomenon so immense and enigmatic that it forces us to rethink the very fabric of reality. Picture, if you will, a region of space where gravity is so intense that not even light can escape, where time itself slows to a crawl, and where the rules of physics as we know them begin to unravel. That's the world of NGC 4261. What makes this galaxy particularly fascinating is the sheer scale of its central black hole. We're talking about an object with the mass of billions of suns packed into a space smaller than our solar system. The gravitational pull is so extreme that it warps spacetime around it, creating a vortex that distorts the very structure of the cosmos. But here's the kicker: this black hole isn't just sitting there quietly. It's active, spewing out jets of particles at nearly the speed of light, stretching across thousands of light years. These jets are like cosmic lightning bolts, illuminating the galaxy and leaving astronomers in awe of their power and precision. Yet, NGC 4261 isn't just about raw power, it's also a window into the past. The galaxy itself is ancient, a relic from a time when the universe was still young. Its stars have witnessed eons of cosmic history, and its black hole has been influencing its surroundings for billions of years. When we study NGC 4261, we're not just looking at a galaxy, we're peering into a time capsule that holds secrets about how the universe evolved. But as much as NGC 4261 teaches us, it also leaves us with more questions than answers. How does a black hole of this size form? What happens to matter as it crosses the event horizon? And what does it mean for our understanding of gravity when the rules seem to break down in its presence? These are questions that keep scientists up at night, and NGC 4261 is at the center of that mystery. Now, as we marvel at the ancient beauty and profound enigma of NGC 4261, let's turn our gaze to another galaxy, one that doesn't just challenge our understanding but seems to rewrite the laws of physics entirely. What happens when a galaxy appears to break the rules? That's where our journey takes us next. NGC 7742 is no ordinary galaxy. Picture this, a shimmering ring of stars and gas swirling gracefully around a luminous core like a cosmic jewel. This unique structure makes NGC 7742 stand out in the vast tapestry of the universe, but it also raises some fascinating questions. How did this ring form? And what does it tell us about the forces shaping galaxies? Unlike most galaxies where stars are distributed more evenly, NGC 7742 ring is a concentrated band of star-forming activity. Scientists believe this ring might have been created by a collision or a close encounter with another galaxy billions of years ago. The gravitational tug of war between the two galaxies could have disrupted their structures, leaving behind this stunning ring as a cosmic fingerprint. But here's the twist: NGC 7742 doesn't show the usual signs of a recent collision, like distorted arms or chaotic debris. This has left astronomers scratching their heads, wondering if there's another explanation for its formation. The ring itself is a hotbed of star formation, glowing with the light of young, massive stars. These stars burn brightly but live fast and die young, leaving behind supernova and neutron stars. This intense activity could be reshaping the galaxy from within, adding another layer of complexity to its evolution. What's even more intriguing is that the ring might be influencing the galaxy's central black hole, feeding it material and causing bursts of energy that ripple through the cosmos. But for all its beauty, NGC 7742 is more than just a pretty face. It challenges our understanding of how galaxies evolve and interact. Its existence suggests that there are still many mysteries hidden in the universe waiting to be uncovered. And while NGC 7742 leaves us with more questions than answers, it also reminds us of the endless surprises the cosmos has in store. Speaking of surprises, let's shift our gaze to another enigmatic galaxy. One that doesn't just glow with starlight but emits mysterious gamma rays, the most energetic form of light in the universe. What could be powering such intense emissions, and what does it reveal about the hidden forces at work in the depths of space?